All right, let's unpack a really powerful architectural pattern that can, dramatically simplify your client applications. It's called server in-memory joins. Now, I know that might sound a little complex, but stick with me. By the end of this, you're going to see it as this super elegant and honestly essential tool for your developer toolkit.
So picture this. It's a classic scenario, right? You've got your tasks in one service and all your users in a totally separate contact service. Now your front-end app needs to show a list of tasks, but for each task, it also needs to show who it's assigned to, the contact's name. How do you actually pull this off without making your client app feel slow and just way too complicated?
Well, the most obvious way is to just make the client do all the work. First, it asks for the list of tasks. Then, for every single task that comes back, it has to make another call to the contact service to get the user details. This is what we call a client-side join. And yeah, it works, but it is so inefficient. It creates a ton of network noise, and at the end of the day, it just leads to a clunky user experience. To fix this, we've got to think about the problem a little differently. Instead of sending your client out to all these different stores to grab different bits of data, what if your server could act like a personal shopper? The client just hands over a single shopping list, and the server does all the legwork. It goes to the different services, gathers everything up, and then brings it all back in one nice, neat package. That whole personal shopper idea, well, that is exactly what the server in-memory join pattern is all about. It lets the client make one single simple request, while the server deals with all the messy details of fetching and combining data behind the scenes. Let's get into the official definition here. A server in-memory join is when your service combines data from another service during a read operation. And here's the absolute key part. It does this only at the API level. What that means is that your underlying data models, your core domain entities, they stay totally separate. This join is just a temporary thing, stitched together right there in memory just before the response gets sent back. Okay, so let's walk through how this actually works step by step. First, the client makes a single request, something like, hey, get me all the tasks. The server gets that primary data from the task service. Then it looks at those tasks, grabs all the contact IDs, and makes a second internal call over to the contact service to get the matching details. Now, here's where the magic happens. The server merges that contact info right into the task data, all in memory. And finally, it sends back a single, rich, combined response to the client. From the client's point of view, it's simple, clean, and super efficient. So, what's the big deal? What's the payoff here? Well, this pattern gives you some fantastic benefits, especially when it comes to keeping your APIs and your client code just wonderfully clean and simple. Really, there are two huge wins here. First, you get a much cleaner API. The folks working on the client don't need to know or even care that the data lives in two different microservices. They just ask for what they need and poof, they get it. Second, you get way better performance on the client side. Fewer network requests just means a faster, much more responsive app for your user. And this quote just nails it. The client is completely, blissfully unaware of all the complex stuff happening on the back end. All that complexity is hidden right where it belongs, on the server. For the client, it's just one call and one response. It is a beautiful, beautiful abstraction. And you knew there was a but coming. Like any architectural pattern, this is not a silver bullet. It comes with its own set of trade-offs and some hidden complexities that you absolutely have to understand before you decide to jump in and use it. Okay, this is the big one, the biggest trade-off. Because the join happens after the server fetches the first batch of data, you cannot filter that primary data based on fields from the related data. For example, filtering your tasks by their status? No problem, that works perfectly. But trying to filter tasks by the contact's city? That's a no-go. The task service has absolutely no idea what a contact city is, so there's no way it can perform that filter. To solve that specific problem, filtering across different services, you have to reach for a much heavier pattern called materialization. That's where you actually copy and store the related data together. It's a whole other can of worms, really, but the key takeaway for right now is that in-memory joins just can't do it. And the trade-offs don't stop there. There's no built-in framework for this. You have to write custom code for every single join you want to create. You also have to remember to apply that same joining logic everywhere, including in your bulk operations. And another thing, since the join is temporary, if a contact's name changes, the task entity doesn't know. It won't fire off any events. The update only shows up the next time you happen to read that data. And finally, let's not forget that your server is now making extra calls across your internal network. This can add a little bit of latency, but maybe more importantly, it introduces a new point of failure. If that contact service goes down, well, your request to get tasks might just fail right along with it. You're creating a tight dependency, and you have to be really mindful of those cascading failures.
Okay, so we've seen the good, we've seen the bad. The big question now is, when does this pattern actually make sense? What's the architect's rule of thumb here? You should probably reach for this pattern when a few key things are true. First, reading these two types of data together is a super common thing in your app. Second, you really value a clean and simple API for your clients. Third, doing the join on the client side has just become genuinely awkward or inefficient. And finally, and this is the most critical one, you do not need to filter across the two different entities. This all leads to a fantastic mental model from the engineers at Wix, which they call the three-step ladder. It's brilliant. Always start simple on the first rung. Use client-side joins. When that starts to get painful or clunky, level up to the second rung, server in-memory joins. And only when you absolutely need that cross-entity filtering or you're facing massive scale, do you climb to the top rung and use a more complex pattern like materialization. It's just a really practical way to scale up complexity as you need it. So there you have it. The server in-memory join is this powerful middle ground solution. It's way cleaner than a client-side join, but it's a lot simpler than full-on materialization. Now that you know the trade-offs and you have a framework for making the decision, the only question left is which approach is the right one for your next feature.